Okay, let's talk about how we graph the secant and the cosecant trig functions. Okay, so here we have, first off, starting at y equals the secant of x. Okay, so if you know anything about your trig functions, and hopefully you do, you know that the secant is the inverse of the cosine. Okay, so we could start off by making a table. So let's do that. So let's make a table. It's a really long way to do it, but we can do it anyway. So here's an x value, or rather an angle measure, and here is the secant of that angle measure. Okay, so let's start with 0. 0 degrees. Secant of 0 is, well, it's 1 over the cosine value at 0. Now the cosine value at 0 is 1, so 1 over 1 is 1. So we can put a nice dot here at 1. Secant of 1 is 1. So let's move over a little bit. Let's go to pi over, let's do pi over, oh, I don't know, pi over 3. Okay, 30 degrees. Pi over 3. So we're looking at the secant of pi over 3, which is 1 over the cosine of pi over 3. So we know that the cosine at pi over 3 is 1/2. Okay, cosine of pi over 3 is 1/2. 1 over 1/2 is 2. So let's go over here, pi over 3 units. There we go. And now we're up here at positive 2. Okay, let's go left. Left pi over 3 units. You can imagine that it's going to be, cosine is now still 1/2. So the cosecant is now still 2. So here we go over pi over 3 units, and we are up 2. And you say, yeah, so what? Who cares? Well, good question. What about if we go to pi over 2? A little bit more to the right. Pi over 2. The cosine at pi over 2, 90 degrees. The cosine is 0. So if we have 1 over 0, that is an undefined value. So here we have pi over 3. A little bit more to the right is pi over 2, and we have undefined. So whenever we have an undefined value in mathematics, we put an asymptote there. The graph will come close to, but will never touch pi over 2. Okay, the cosecant does not have a value. So if we go left to negative pi over 2, guess what's going to happen here also? It's going to be 0 again, and we're going to have another asymptote, another undefined value. So what's nice is that these graphs of secants and cosecants have these undefined values, and we actually graph them to look like parabola. Okay, now of course you say, but Manchester, that's just one little tiny piece of the graph. Cosecant goes on forever and ever and ever, or rather secant, and cosine does too. And you know what? You're correct. So let's do the short way of graphing secant. Now that we know a little bit about it. So secant, I said, is friends with the cosine. So it helps if we will first maybe graph the cosine. Okay, so we're going to sketch the cosine graph. Okay, cosine standard period is 2 pi. So let's extend this line over here a little bit so we can get 2 pi. There's pi over 2. There's pi. There's 3 pi over 2. Here's 2 pi. Okay, so cosine starts at 1 and ends at the period at 1. Halfway in between, it's at its minimum of -1. Okay, so we need to know this. These are things you should know about the cosine graph. Okay, it starts at +1, goes down to 0 at pi over 2, hits -1 at pi, hits back to 0 at 3 pi over 2, and then is up here at +1 at 2 pi again. Okay, and then of course it will go down, and the same thing on the left. We'll go down to -1 here at negative pi, and back up, and so on and so forth. Okay, so there's cosine. Now if you notice, the asymptotes of secant always correspond with when cosine is 0. So every time cosine is going to be 0, the secant is going to have an asymptote. So every time the cosine graph crosses the x-axis, the secant is going to have an asymptote line. Because their cosine is 0 and 1 over 0 is undefined. So we have an asymptote there. Now what's really nice is it turns out that these graphs, secant, whenever cosine has a maximum, it has a parabola that goes up. And whenever cosine has a minimum, it has a parabola going down. Because it can't cross your x-axis again, it has to go up if it's positive, and it has to go down if it's a minimum. So the graphs of secants are all of these parabola-looking things, from positive and negative 1 on your cosine graph that have asymptotes everywhere the cosine crosses the x-axis. Okay, now that's the quick and nice, easy way to do it. The long way is, of course, making a chart. You would have to make tons of different charts to plot all of these points. So, sketch the cosine. Wherever the cosine crosses the x-axis, you have an asymptote. And from the maxes and the mins is where you have your parabola. So let's move over here and do a more challenging problem. Y equals 2 secant of 2x plus 3. So let's talk about what all these things do. This first one is an amplitude change, so it makes it grow really fast. This one is a period adjustment. And this one, sorry, this is going to be blue. This one makes the graph go up, or a vertical shift. Ooh, let's see, I don't even see, you can see that. It says vertical shift. So let's do these things one at a time. First of all, remember that the secant is friends with the cosine. So we're going to sketch this graph. We're going to sketch 2 cosine 2x plus 3. Okay, that's what we're going to sketch. And then from those points of maxes and mins, we're going to put in the secant. Okay, so let's see. The period equals 2 pi over b. So if we had the period equals 2 pi over b, remember this is your b value, the thing in front of x, that means we have a period of pi. Okay? So our cosine will make one complete revolution or oscillation by the time it reaches pi. So let's see, here's our friend pi. It really doesn't matter how far you put it out there, especially if you don't already have a grid on your paper. And there's 2 pi. Here is negative pi on that side. Okay, so now we're going to move our graph up 3 units. So let's do that in another color. Let's do that in green. So here we have 1, 2, 3. 3 units up. This is our new midline. Now the midline is normally your x-axis, the thing that separates it into a top part and a bottom part. But now we've moved our midline up 3 units because of this plus 3, that vertical shift right there. So that's our new midline. Now, where does cosine start? Cosine starts at 1, but because we have an amplitude of 2, cosine is going to start at 2. So 2 units above the midline is when cosine is going to start, and then of course the minimum will be 2 units below the midline. So remember, you need to know cosine starts at the maximum and it ends at the maximum. So our period is pi, so it ends at its maximum there at pi also. Then it has a minimum halfway in between here. Okay, it's nice to know, but not perfect, that this is pi over 2. But you know, it might help you somewhere along the line. So let's do some more. We have a minimum over here again, and then another maximum up here by my per, and then another maximum over here at negative pi, and a minimum down here halfway. Okay, so I'm going to sketch in my cosine. Sketch in my cosine graph. It goes from high to low and from low to high. Trying to make it look like a nice wave. Okay, do your best to make it look like a nice wave. And remember, we're doing this so that we can figure out where its maximums and minimums are, as well as where our asymptotes are. So everywhere it hits the midline, everywhere your cosine graph touches the midline, your secant is going to have a asymptote. So here we have a bunch of places where the cosine graph crosses your midline. Before it was your x-axis, that's because your x-axis was your midline. But now we've moved our midline up 3 units, which means our asymptotes cross up here too. Okay, so we graph our cosine so that we can figure out where it crosses the x-axis. Now that we have that on there, let's graph our actual secant. So secants are parabolas from the maxes. The max it goes up, the min it goes down. Try to stay in between your asymptotes if at all possible. I know this graph isn't the best and I'm using my finger on an iPad, so do your best also to keep your parabola in between your asymptotes as you graph secant and cosecant. But this is just secant, the inverse of the cosine. So if you were going to be graphing cosecant, you would want to sketch sine first and figure out where it had asymptotes. And that's where it also crosses the x-axis. But for this time, this is just secant. Okay, so here we have your secant graph, and you have your adjustment. Hopefully this has helped. I'll be right back with some cosecant.